On May 10, 2024, something happened that confused a lot of people. People in Florida looked up at the sky and saw it glowing pink and green. People in Texas, people in Mexico, the entire internet erupted in photos of something that's only usually visible near the North Pole. The northern lights had shown up basically everywhere, and most people had no idea why. The answer? The sun had just thrown a solar storm our way. Scientists called it the strongest solar storm in over 20 years, and it reached the highest possible rating on the Space Weather Danger Scale. But here's the scary part. That storm? It was actually pretty mild compared to what the sun has done before, and compared to what it could do again. Today we're going to talk about solar storms. What they are, what they've already destroyed, and why some scientists say the next big one could knock out the power grid for months. Okay, quick sun basics, because you need to understand what you're dealing with here. The sun is not just a giant light bulb floating in space. It's a massive ball of super hot plasma, which is basically a gas where the atoms are so energized that electrons fly off them. And this plasma is constantly moving, twisting, and doing weird things because the sun also has an enormous magnetic field. Think of the sun's magnetic field like a bunch of rubber bands wrapped around a spinning ball. Over time, the rubber bands get twisted and tangled because different parts of the sun spin at different speeds. When they get tangled enough, they snap. And when they snap, they release an explosion of energy that dwarfs anything humans have ever created. That explosion is called a solar flare. A solar flare can release the energy equivalent of billions of nuclear bombs, all in the matter of minutes. But the flare itself isn't even the most dangerous part. Sometimes when a flare happens, the sun also hurls a giant cloud of charged particles into space. This cloud is called a coronal mass ejection, or CME. It can be 30, 40, even 50 times wider than the entire Earth, and it can travel at over 1 million miles per hour. When one of those is aimed at us, that's a solar storm. Here's where Earth's invisible superpower comes in. Our planet is surrounded by a magnetic field called the magnetosphere. It's basically an invisible force field generated by the liquid iron spinning inside Earth's core, and most of the time it deflects the solar wind, which is the constant low-level streams of particles the sun sends out every day. But when a CME hits, it's like a fire hose versus an umbrella. The CME slams into the magnetosphere and compresses it. It warps it. It forces huge amounts of energy into Earth's magnetic environment, and that energy has to go somewhere. It travels down towards the poles, and when those charged particles slam into the atmosphere, they collide with gas molecules and release light. That's what the northern lights are. Solar particles crashing into our atmosphere like millions of tiny fireworks. But the aurora part is the pretty part. The part scientists worry about is what happens underground and inside power plants. According to NOAA's Space Weather Prediction Center, when a geomagnetic storm hits, it creates electrical currents in the ground itself, and those currents find their way into any long conductor they can. That means power lines, pipelines, transformers, railroad tracks. NOAA rates geomagnetic storms on a scale from G1 minor to G5 extreme. G1 can mess with satellites and phone signals. G5 can collapse power grids. The May 2024 storm was a G5. And it caused problems. GPS disruptions, radio blackouts in some regions, satellite orbit changes, but the grid held. The 1989 storm did not hold. March 13, 1989, 2:44 in the morning. A CME slammed into Earth's magnetic field. The ground under Quebec, Canada started generating electric currents, forced there by the storm. Those currents ran into Hydro-Quebec's power transmission lines. 90 seconds later, the entire province of Quebec went dark. 6 million people lost power, and they didn't get it back for 9 hours. It was winter. People woke up to cold homes, cold food, no light. People got stuck in elevators. Across the United States, over 200 power grid problems erupted within minutes of the storm hitting. 50 million Americans came within a hair's breadth of the same blackout. The US only avoided it because they had enough spare capacity to absorb the stress. NASA's TDRS-1 communications satellite recorded over 250 separate malfunctions from the storm. The Space Shuttle Discovery was in orbit at that time and had its own unexplained sensor failures. Research on the type of electrical surge that took Quebec offline has since shown that these currents are one of the most serious threats to modern power infrastructure. Quebec actually spent $2 billion over 6 years upgrading its grid afterwards specifically to resist future storms. And here's the thing, 1989 was a bad storm, but not the worst storm, not even close. Let's go back to 1859. On September 1st of that year, a British astronomer named Richard Carrington was sketching sunspots through his telescope when he witnessed something that had never been recorded before. A sudden blinding bright flash of white light erupting from the sun's surface. That was the first observed solar flare in human history. 18 hours later, Earth felt it. A coronal mass ejection from that flare hit Earth at over 900 miles per second, one of the fastest ever recorded. It would rate as a G5 on today's scale, but some researchers believe it may have been at least twice as powerful as any storm in the past 500 years. The effects were unlike anything people had seen. Auroras lit up the sky so bright that people woke up thinking it was morning. Miners in the Rocky Mountain got up and started making breakfast at 1 a.m. because the sky looked like dawn. And the telegraph, which was basically the internet of 1859, went completely haywire. Sparks flew from machines, some operators were shocked, telegraph papers caught on fire, and in one of the strangest moments in the history of technology, telegraph operators discovered they could unplug their machines from their batteries and still send messages using only the electrical currents in the air from the storm. Now, here's the question you should be asking. What would the Carrington event look like today? Scientists have modeled this. The answer is not reassuring. Today, instead of telegraph wires, we have millions of miles of high-voltage power transmission lines, undersea internet cables, GPS satellite networks, and financial systems that run entirely on electricity. A Carrington-level storm today could cause geomagnetically induced currents powerful enough to burn out large power transformers across the continents. These transformers are not easy to replace. They can take over a year of manufacturing and shipping. 2013 assessment noted that a similar event could result in blackouts lasting months, affecting tens of millions of people and economic losses running into the trillions. The good news is that we are not completely in the dark on this. NOAA Space Weather Prediction Center monitors the sun around the clock. When the solar flare occurs, they can detect it in 8 minutes. That's how long it takes the light to travel from the sun to the Earth, and CME itself takes between 17 hours and 3 days to arrive, depending on how fast it's moving. That gives scientists a window to issue warnings. In 2013, the Federal Energy Regulatory Commission ordered power grid operators across North America to start testing for and protecting against geomagnetically induced currents specifically. There are now international protocols for reducing power loads on vulnerable parts of the grid when a major storm is incoming. The May 2024 G5 storm was actually a test of these systems, and while there were problems, there was no catastrophic grid collapse. Scientists are still studying the data from the storm, and NASA researchers stated that we'll probably be studying this event for years. But scientists also acknowledge they can't always know exactly how strong a CME will be when it arrives or which direction its magnetic field will be pointing. That last part matters a lot actually. A CME whose magnetic field points southward causes far more damage than one pointing northward. And we often don't know the orientation until the storm is about 30 minutes away. The sun runs on an 11-year cycle, cycling between periods of low activity and a peak called the solar maximum, where flares and CMEs are more frequent. We are currently in solar cycle 25, and we are near or at the solar maximum right now. That means the sun is as active as it's going to be for this cycle. The 2024 G5 storm happened during this peak. More storms are coming. Whether one of them will be a 1999 level event or a Carrington level event or something in between, no one knows. What we do know is that the sun has done this before and it will do it again. And the more technology we depend on, the more these storms matter. The northern lights over Florida were beautiful, but they were also a warning. Thanks for watching. If you want to see more videos about the extraordinary things happening in our world right now, subscribe, because I've got a lot more where that's coming from.